Good evening, everybody. Thank you for joining us here. I'm Amanda Liberty with the Rangeley Lakes Heritage Trust. This evening's program is part of a series of Dark Skies events we've got planned for you in 2024. Our next sky tour will be on March 12th at the Rangeley Lakes Trail Center. And then following that, we'll be celebrating International Dark Sky Week from April 2nd to April 8th, and it'll end with the total solar eclipse, which Rangeley will be in the path of totality. A few events that we have that week. We're doing home and business inspections, stargazing on snowshoes, a mini dark sky festival, a coffee and constellations talk. We're doing some cosmic yoga and sound bathing under the stars, a lights out event, and an astrophotography meetup. And that's just a few of the things. There's so many more things on our community calendar, so please check us out. Tonight's night sky tour is sponsored by Dark Skies Rangeley. It's a community-led effort to conserve our dark sky. And with that, I'll hand it off to John Meter. Thanks for joining us tonight, John.
Thanks, Amanda. It's nice to be here. Wish I was up there with you guys at the touring center, but we're here this evening for various reasons of interpreting the weather. So I'm going to take the screen here, and we're going to jump right into some Stellarium, which is the program I use to share the stars with you this evening. I'm going to shut my picture off so I don't have to look at myself. There we go. People often ask me, what is the program you're using? Because they seem to like what we can do with it. It's called Stellarium. It's a free program. You have to go to stellarium.org. I don't think it's in the App Store or, the game store or whatever your thing is, but it's available for both Macs and PCs. It's available for tablets, and it's available for your phone. I do believe they charge for the phone version, but with the phone version, you can take it out and hold it up, and it'll show you what you're looking at. So it does a little bit more than the version I'm using here tonight, which is on my laptop. But it's really intuitive and easy to use. So enough of that. I just like to plug that because people do wonder, and it's easy to use and it's free. So this is the sky right now. So we're at the touring center right now, and it's clear. This is pretty much what it's going to look like. You see, we're looking to the southwest. And the first thing you're going to notice if you step outside tonight after the presentation, and it's clear, is you're going to notice one very, very bright star, which is right over here in the southwest. It's going to catch your eye. It's definitely the brightest thing up there this evening. And when you find it, if you have a pair of binoculars, you should check it out, because that's not actually a star. That's a planet, and it turns out to be the planet Jupiter. Now, Jupiter's 440 million miles away right now. That's a pretty healthy distance. Even though it's the largest planet, it just looks like a bright star. Kids always expect it to look really big in the sky, and it doesn't look big, it looks bright. Being that distance means it's going to look stellar, but being large means it reflects a lot of sunlight. Planets don't glow on their own, they reflect sunlight. So if you have a telescope or a pair of binoculars, let's see what you might see. With binoculars, you might see something about like this. Now, you see the thing in the center inside those four red little lines that are fluctuating in and out. That's Jupiter. And these other four objects on each side, three on the lower side and one on the upper, are moons, and they look bigger than Jupiter. That is one of the downsides of this program. They overemphasize the moons. They're going to look smaller than Jupiter. They're going to look like stars, very little pinpoints, but they're always in a straight line. As we move in, that goes away just a little bit. They're still going to look smaller in your telescope than they look here. This program is just emphasizing it so you don't miss them. You see, Jupiter actually has over 90, I think it's 96 moons going around it. Most of them are very tiny, which you won't see with a backyard telescope. With your backyard telescope, you can see the four large Galilean moons, named after Galileo Galilei, who first saw them in 1610. Now, some nights you go out and you can't see all four. And if you haven't noticed them, this is Jupiter. This is this one, this one, this one, and this one way out here. Those are the four Galilean moons. Io is the one in closest right there. And this one, I believe, is probably Europa. Yeah. And the other two would be Callisto and Ganymede. And I guess this is Ganymede. Oh, I got it right. And Callisto's down here. These are all as big as our moon, if not larger. And if you go out tonight, you're going to have three on the lower side and one on the upper side. Tomorrow night, they're going to be in a different configuration. They're orbiting, and we're looking at the orbit edge on, so they look like they move back and forth like this. Some nights you go out and you only see three moons. That would might be because one of the moons is behind Jupiter. If you look at Jupiter itself, what you'll notice in your telescope are those two dark lines. Now here you see nice color. You might see the lines look kind of red, rusty red, surrounded by white. In your telescope, you're not going to see any color. You're going to see the two dark lines. They're going to look gray. The part of our eyes that sees faint light turns out to be colorblind. If you take a photograph through through your telescope, the color will often come through, but with our eyes, it's going to look black and white. But they do show up, and those are cloud bands. Jupiter is a gas giant. There's no ground on Jupiter. We're never going to land rovers there. No astronaut is going to land and walk around on Jupiter because there's no ground to walk on. It's clouds and gases, and the wind blows through these clouds at over 100 miles an hour. This lower brown band here blows to the west at around 100 miles an hour, while the white band in between goes to the east at 100 miles an hour, and back and forth the winds blow, stretching the clouds in these wild bands. And they show up pretty well. So those are the things you want to look for, the two cloud bands and the four moons of Jupiter. So that's the first thing you really want to explore if you go outside. And even if you don't have binoculars, it really does stand out bright. And it's just something to contemplate that planet is 1,000 times larger than the Earth in volume. So it's very, very big. And it's 440 million miles away. So just something to consider when you're looking at Jupiter. And at 8 o'clock right now, it's really the only planet you can easily see with your eyes if you go outside. Once you find Jupiter, a lot of people can notice if you look off to the south, there's a reddish orange star right here. And if they've been looking and they found Jupiter, they often think, well, that must be Mars. And it actually has about the same brightness as Mars and the same color as Mars. Mars is red because it's a rusty planet. Mars has ground, and the ground has rust all through the soil and rocks. This is not Mars. This is a red star named Betelgeuse. And Betelgeuse, it marks the shoulder of Orion the Hunter. So to see Orion, and this is a really uh, outstanding wintertime constellation. It's kind of the the cream of the crop of constellations in the wintertime. To see Orion, look for these three stars in a row right here. That's Orion's belt. It's right beneath Betelgeuse. Betelgeuse and Bellatrix are the man's two shoulders. We put some lines on him if you like here. They draw them like this. I don't personally, I don't draw them this way. I draw them a little differently. These are his two legs coming down, one here and one here. And I never draw a line between his feet. That's like tying someone's feet together. I'm always afraid he's gonna fall down or something. So I don't draw that line. I draw his legs, his belt, and I draw a line between his shoulders, then just a line up to his head, which is this little clump of stars. This is an arm with a club, and this is an arm with a shield. Sometimes you'll see this drawn as a shield. Sometimes it's the skin of a lion because there's a story about Orion slaying a lion. Sometimes it's drawn as a bow for like a bow and arrow. And then if you look at how his belt's pulled down to one side, you can see just below it, these stars below. Draw a line down that, and that's his sword hanging from his belt. And that's what tugs his belt down. Now, you might say, well, how are you supposed to draw it? It really doesn't matter how you're supposed to draw. There's no right way. Officially speaking, Orion is everything inside this red polygon, and you can draw the lines any way you want. So if you find this app and then you get another app like Sky Safari or, there's a dozen different apps out there, you'll find they all use the same stars, but they'll draw the dot to dot lines differently. When I first started learning constellations, my mom bought me this book from National Geographic, and it had pictures of constellations like this. And I thought they were beautiful. And I went outdoors and I held up the book and I looked at the stars, and I couldn't see pictures like that in the sky. I couldn't even begin to do it. And I got really frustrated because I was a kid and all I had was this one book, and it had to be right because it was the National Geographic after all. And it wasn't wrong, but it didn't help me learn. Years later, I found a book that drew the constellations with lines like this. And it doesn't make as fancy a looking man, but I could start to imagine a person out of this. So that's the way I like to do them. And you develop your own way of seeing it. So use the app to get started, but if you see it another way, that's totally fine. Now, Orion, you can see he's got his shield up and his club raised because he's fighting with Taurus the bull. Now, the bull has two long horns, you see here. This little triangle shape is a group called the Hyades, and that marks the bull's face. The bright star Aldebaran might be his eye. His back comes up to another little clump of stars up here known as the Pleiades, the seven sisters who are riding on the back of the bull. Now, I draw the bull a little more complicated. This is one front leg, but I draw another leg down to these stars, so we have two front legs. He's charging at Orion. Then I draw a line up here for a belly, up to these stars right here. So he's got a body right in here. It's the front part of the bull. There's no hind legs or tail. It's just the bust of the bull, but he's charging at Orion. That's why Orion has his shield up and his club raised, ready to clobber them. If we use the classic drawings, you can perhaps imagine that a little bit better. It does help your imagination perhaps picture these stories in the sky that were made up. And there were stories about Orion. He was fighting the bull to save the seven sisters. And there are stories where the bull is trying to save the seven sisters from Orion. It depends on the perspective, I think, of who you're looking at. Because in mythology, the bull is represented by Zeus. But Zeus didn't always have the best of intentions. Now, Orion and the bull are not in the sky alone. Orion has his two best friends beside him, Canis Major and Canis Minor. That's the big dog and the little dog. To find the big dog, just draw a line down through Orion's belt, and it'll point you to the bright star Sirius. Now, that's the brightest star in the entire night sky. Jupiter, which we saw earlier, which is over here, is going to look brighter, but Jupiter's not a star, it's a planet. Of the actual stars, Sirius is the brightest star you'll ever see outside at night. There's only one star brighter, and that's the sun. And the sun doesn't come out at night. When the sun comes out at night, it turns it into daytime, right? So Sirius is the brightest star, and it marks the nose. The way I draw it, it's the nose of Canis Major. The way this program does it, it's his collar. So let's show you how the program does it. This is like a studded collar. Then the triangle is his head. I usually call this his nose and call this an ear and this an ear, and I ignore that little star right there and just make a triangle-shaped head like he's looking at us. Your choice. You can do it any way you like. Then we've got a body, two front legs, two back legs, and a tail here. So not a bad dot-to-dot dog, but I said he had two dogs. This is Canis Major. Canis Minor is a little bit more challenging. You go from Sirius up past the dog's ears or past his nose to the next bright star, which would be this one. That's Procyon. And I use that as the little dog's nose. So far, so good, right? Well, once you find his nose, just draw a straight line back to this star, and that's his tail. And that's all there is to the little dog, just two stars, one at each end. Kids often like to call that constellation the hot dog because it looks more like a hot dog than a real dog. So we got quite a scene up here in the southern sky tonight. You got Orion, he's fighting the bull, and you got these two dogs over here jumping around because they're all excited about the battle going on. They draw the little dog backwards from the way I do. I draw him the other way because I like the bright star to be his nose, but that's me. You can do it the way you like. If you like it that way, so they're both looking towards the bull, then that's totally fine. So these are really key constellations of the winter. And what I like to do at this point is take a little bit deeper dive into them because there's some really interesting things you can see here. And all you need is a pair of binoculars. And I'll tell you what you can see with binoculars and what you need a telescope to see, because we're going to do a little bit of both. And some of this you can see with just your eyes, but a lot of it you might want that pair of binoculars to get started. And if you want to go deeper, you need a telescope. So start off with Orion. Let's just shut these lines off for a second and just bring back Orion all by himself. And remember that sword I showed you drawing hanging down from his belt? Well, if we zoom in on that sword, you're going to see that it looks a little fuzzy right in there. Let's go closer. It looks kind of like there's a little fuzzy cloud in there. Well, that's kind of what it's going to look like in binoculars, like a fuzzy cloud. In a telescope, it's going to have a little more structure. It's going to look something like this. This is called the Great Orion Nebula. Something that's nebulous is cloud-like. And that's pretty much what it is. It's a giant cloud of hydrogen gas. Now, hydrogen is what stars are made of. All stars are made of hydrogen. In their core, they may be like the sun is turning hydrogen into helium via nuclear fusion. That's what makes stars shine. But they're, 99% of their mass is hydrogen. This is a cloud of hydrogen, with enough hydrogen in it to make maybe 400 stars like our sun. So it's very large. From one side to the other, it's about 40 light years across. Now, a light year, don't get confused. It's not a length of time, it's a distance. The way an inch is a little distance and a mile is a bigger distance. A light year is the distance a beam of light will travel in a year's time. And light travels at the incredible speed of 186,000 miles per second. You go that fast in a straight line for 1 year, you're going to cover some miles. That distance would be 1 light year. From one side of this to the other is 40 light years. So it's really big, but it's shrinking. It's shrinking down. Gravitational attraction between the molecules is pulling them together. That's what gravity does. And it starts clumping in the center here. And each clump, once it starts to clump, it has more gravity. So it pulls more gas in, and the clump gets bigger with more gravity and pulls more gas in. And eventually the pressures in the center of that clump get so great that nuclear fusion starts to take place, turning the hydrogen into helium. And at that point, that clump becomes a star. This is the birthplace of stars. And we find these nebulas scattered all over the sky. If you go up here and to the east of Orion, you're going to see another one. This one takes the Orion Nebula, you can see easily with binoculars. And by the way, as pretty as that is with all the color, if you take a photograph, it is red. You'll see the color. With your eyes, it's going to look white. This one's called the Rosette Nebula. This one is a little bit larger and a little bit further away. It's the Orion Nebula was 1,500 light years away. This one's about 5,000 light years away, but it's 115 light years across. So it's much, much bigger. And it's very beautiful when you take pictures of it. It's quite faint with your eyes alone. Here it looks bright because this is a photograph, obviously. And if you look in the center, it looks like there's a hollow place in the center with a whole bunch of new stars. These stars might be, maybe 100 million years old, which sounds old. But for a star, that's kind of like being, a middle school kid, preteen to teen. And so this is stars forming out of this nebula. And as they start to shine, their energy pushes the nebula away, creating this opening in the middle with young stars in it. Then more stars will form around the edges. All these dark areas are knots filling up, which might eventually become stars. So it's quite a sight to see and a beautiful one to photograph. So we find these nebulas all over the sky. Now, if these are the birthplace of stars and these nebulas can form several hundred stars, we should be able to find places where that's already happened. The most famous one is the Pleiades, the seven sisters. Remember the Orion's fighting to save? Well, the seven sisters are an open cluster of stars. Open clusters are usually young stars, and these stars are about 80 million years old. And if you look at them, the best way to see this is not with a telescope, but with binoculars. Binoculars look at a large part of the sky, whereas telescopes will look at a smaller part. And this is a large enough group and close enough to us that when you look at them with a telescope, you can't see the whole group in one view. You have to move around, whereas binoculars will show it that way. So they're very beautiful, look like a little pile of diamonds. If you take a photograph of them, then you get to see some of the nebulosity around them. For a long time, we thought that was what remained of the nebula they formed from. But what we've learned is that the nebulosity is not associated really with these stars. It's floating between us and the stars. Remember, space is three-dimensional, and the light's just shining through that nebulosity. If the nebulosity was still around the stars, they'd be glowing red. When that gas is close to the hot stars, these stars give off ultraviolet light, and they excite the atoms in the nebulosity, make it glow red. That's why those others are red. If the gas is further away and the light from the stars, by the time it gets there, it's not energetic enough to excite the molecules and make them glow, it'll just light them up. And when it lights them up, then the hydrogen looks a bluish white color, like you see here. So this is reflecting light, whereas when you see the nebula that looks red, the red is because the gases are actually glowing from the energy of the nearby stars. Now, there's one more open cluster I'd like to show you. So open clusters, remember, are young stars. Go down to Canis Major, the big dog, and Sirius. And just go to the left over here or to the east. There are actually two open clusters here, but there's one in particular I really like. And they're side by side. The easy one is not my favorite, but we're going to start right there. The easy one is called M47. That's this one you're looking at right here. And M47 is about 1,500 light years away. And the stars are about 70 million years old, very similar to the Pleiades. So you can see them right here. These are all the young stars. The one I like is a little bit further away. It's M46, and it's looks smaller, but that's because it's farther away. It's over 5,000 light years away. But when you look at it and you need a telescope to see this well, you can see all these stars here, but you see this little greenish circle here. It looks like a little smoke ring. Again, with your telescope, you won't see that color. That's only going to show up in the photograph. But you'll see this circle with a dark center. That's what's called a planetary nebula. And like the nebulosity of the Pleiades, this is not inside the cluster. This is between the cluster and us. It just happens to be lined up. It's kind of photobombing the scene. Or you might say the cluster is photobombing the scene of the planetary nebula. Now, they're called planetary nebulas because they're round, and when they first saw them 200 years ago, they thought they might be planets. At that point in the 1780s, the planet Uranus had just been discovered, and everyone wanted to find more planets. And they saw these round things. I thought, maybe that's a new planet. It's not. It's a nebula, but it's not like the Rosette Nebula or the Orion Nebula. This is where a star similar to our sun has died. When stars like our sun, of the size of our sun, die, they don't explode. They just end up pushing their outer layers away into space. It's just like a push, and it just goes drifting away, not in a giant explosion. And this is the outer shell of the star expanding outwards. So our sun, when it dies, will create a nebula just like this, which we call a planetary nebula because of the historical way they came to be named. So I like this cluster because you get to see all these young stars, and then you get to see an old dead star floating between them, kind of a reminder of the mortality that even stars don't last forever. Now, some stars do explode, and while we're doing stellar evolution, let's go find a star that did explode. We know exactly when it exploded. It exploded on July 4th, 1054, and that was about 950 years ago. Is right above the inner horn of the bull, right about there in the sky. Let's see how close I get to it here. And when it appeared, when it exploded, it suddenly a brand new star appeared in the sky. The Chinese wrote about it. They called it the guest star. It came, it was very bright, and it lasted about 3 or 4 months, and then it faded away and disappeared. Like a guest, it stayed for a while, then it went away. They wrote that it was bright enough that you could read by the light of this star. Imagine a star so bright at night that you could read a book by it. Yet it's still a pinpoint. It didn't look big. It just was a very bright point. Well, if you look at it today, you're going to find, let's see how close I got here. Not too bad. It's right here. You're going to find an object that looks like this. We call it the Crab Nebula because someone thought at one time that it looked sort of like a crab, apparently. Um, and it was so bright that for 23 days it could be seen in the daytime, right beside the sun. Very bright. It's 6,500 light years away, and it's expanding outwards at all directions at 1,000 miles per second. And this is what it looks like at almost 1,000 years later. So this thing's going to be pretty big too. And when stars explode, they make everything heavier than iron. Stars in their core, like our sun's turning hydrogen into helium. A big star will eventually turn the helium into carbon and neon, and then oxygen and silicon eventually to iron. And once they start making iron, they can't make anything heavier. It takes a lot of energy to fuse iron, more energy than any star seems to have. And at that point, that star will collapse on itself and make one giant explosion that blows itself to smithereens, which we call a supernova. And when it explodes in 1 second, that star will give off as much light as all the rest of the stars in the sky combined. So it's an incredibly powerful explosion, powerful enough that it creates everything heavier than iron. That includes things like silver and gold. So if you have a gold ring on your finger right now, you should realize all the gold, all the silver on the planet Earth was created in a supernova. So that means you have a piece of supernova wrapped around your finger right now. Isn't that cool? And we find silver and gold in this, the signatures of it, which I think is pretty fascinating. So now what I want you to do, let's back all the way back out here so we can see our friends. We see Orion and the big dog, and let's put the little dog up there too. We can actually make their nice little pictures here. But let's just take them down now that we recognize the part of the sky we're looking at. Oh, I hit the wrong button. Let's hit the right button here. There we go. Yeah, we can make mistakes, but it's okay. So this is a pretty nice sky, but I have it set for the skies I would find. I live in Waterville, Maine, and this isn't like from downtown Waterville. It's from the countryside around here. But you guys, or most of you, you either live in Rangeley or you're associated with Rangeley, you're summer in Rangeley or you winter in Rangeley. There are all kinds of great reasons to be in Rangeley. And Rangeley has much darker skies than we have here in central Maine. So let me give you an idea of what they might look like. From Rangeley, this same sky, if it's really clear, is going to look more like this. A lot more stars, right? Can make those constellations a little more challenging to find. We can put the lines back up there again, and you see they're still there, but there are a lot more stars scattered around them. So it does make it a little more confusing, but way more beautiful. So what I want you to notice, though, if you look at those two dogs, let's bring the dogs back up. There's the big dog, and here's the little dog. You notice that, I don't know if you can see it here. I hope you can. It looks a little cloudy right through here, a little whitish, bluish cloud. Goes between the dogs, above Orion and above Taurus the bull. Goes all the way across the western sky, and it sets over here in the northwest. Well, that's our Milky Way, and the Milky Way is our galaxy. And if I look at it from the right angle here, you can see it goes all the way across the sky. It's not as bright this time of year as it might be if we were looking at the sky in August or September or October, because this time of year we're looking towards the outer edge of our galaxy, whereas in late summer and early fall, we're looking towards the center, and there are a lot more stars in the center. But you can still see it, especially if you're in a dark spot like up in Rangeley. For me in Waterville, the sky's going to look more like this, and I can still kind of make it out here. But if I go right into Waterville, then even the Milky Way is just going to disappear from view. So that's because of light pollution, the light from street lights and cars and trucks and signs and all that. So let's go back to Rangeley because that's where you're all at here. And or if you're not there, you probably wouldn't mind being there. I know I wish I was there, but that's okay. Follow this Milky Way past Orion, past Taurus the bull. Let's put them up here so we can stay oriented. There's the bull, and there's Orion, and there's the big dog, and there's the little dog. And over here in the northwest, you can see a nice little W in the sky. Let's zoom in so we can see. It's right in the Milky Way, and it's called Cassiopeia the Queen. And Cassiopeia was the queen of Ethiopia, and she was very vain, and she bragged about her beauty and caused all kinds of mayhem because of that mythology. So when she's placed in the sky, she's designed so that half the night she's right side up and the other half she's upside down as the earth rotates. So that was designed, according to mythology, to teach her some humility. Beneath her, though, what I'm really getting at here is her daughter, Andromeda. She's floating upside down this time of year with her head low in the northwest. This star is her head. Follow my pointer very carefully here because I want to draw it the way I do it. I don't like the. So this is her head. This triangle is her body right here. She's got an arm there and an arm there, those three little stars. Come up to her belt, and she's got a leg here and a leg there. And this little line of stars is the hem of her dress. She's floating upside down. You can do that in space, right? They draw very simply like this, whereas I draw a line down here for make this her body. This is her arm and another arm here. And then I draw a line down here for the other leg with the hem of the dress there. To me, it looks more like a stick person than this. But the reason we want to see Andromeda, if you can see it enough, we zoom in, you can notice there's a little star here that looks a little fuzzy. Well, that's another galaxy. Our galaxy is the Milky Way, and we see that band around. But actually, every star you can see in the sky is part of the Milky Way, except for this one, because this is actually another entire galaxy. It's the next closest galaxy to us. It's called the Andromeda Galaxy. And you can, if you're in a dark spot, you can just barely make it out. If you have a pair of binoculars, it's going to look like another fuzzy patch of light, kind of like the way the Orion Nebula looked, like just fuzzy light, kind of like you see it right here now. Only this is going to have sort of a definite oval shape to it. If you have a telescope or you take a photograph, it's going to look more like this. Quite beautiful. Now, the Milky Way is a spiral galaxy, and so is the Andromeda galaxy. They're similar in size. Andromeda is just maybe slightly larger than the Milky Way. It probably has around 450 to 500 billion stars in it, whereas the Milky Way has 300 to 400 million stars. So they're fairly similar. It is the closest one to us, but it is 2.5 million light years away. So while that is a distance, it is the distance, remember, it's that the speed of light takes to get somewhere. So when you look at it, it took the light 2.5 million years to get from that galaxy to your eye. So when you look at it, you're not seeing it the way it is today. You're seeing it the way it looked 2.5 million years ago. So when you look at galaxies, especially anything in space, you're looking back in time. And the further away they are, the farther back in time you're looking. So this is a really cool one. It's fairly large. It's actually bigger than the full moon in the sky, but its brightness is much lower. So you got to really look to see it, but it's pretty easy to find in binoculars. And you see, we're looking at it. It is a spiral galaxy, but we're looking at it at about a 45-degree angle. There are galaxies we can see straight on. So let me show you one of those. Let's spin all the way around to the northeast, and you're going to find a group of stars that hopefully you're all familiar with. We call it the Big Dipper. The Big Dipper is right here. Now, we're drawing a lot more than the Big Dipper here because technically the Big Dipper is not a constellation. It's what we call an asterism. Constellations are officially designated. There are 88 of them, and they make pictures. The Big Dipper is part of the constellation Ursa Major, which is the Great Bear. That looks like a bear, right? Well, they draw him sort of like this, bear with a long tail, and there are lots of stories about how the bear in the sky gets his long tail. Uh, we don't have time for that today, but maybe another time we can do that. If we meet in March, I'll be glad to tell you a story which tells much better in person than it does on the internet. So we'll just save that one for next time. But to see the Big Dipper, we just use these 3 stars for the handle and these 4 stars for the pot or the bowl. Asterisms are groups of stars that are easy to recognize, sometimes easier than the full constellation. And there are lots of them all over the sky. And this is probably the most famous one, the Big Dipper. In England, they call it the plow, with the handle of the plow, and then they draw a diagonal line for the plow blade. And this is the part that goes up that attaches to the horses. In Germany, it's known as the wagon. And in the Deep South, before the Civil War, it was known as the drinking gourd, and the slaves used it to help them find their way to freedom. Lots of history here with this constellation. Well, I was going to show you a spiral galaxy straight on. The handle of the Big Dipper, the stars of the handle, go to the last 2, and right above it, right about in here, we'll see how close we get this time. And you never know. This one you will not see with your eyes alone. You definitely won't see it with binoculars. You need a telescope to see this one. It's right there. You can kind of see it now here. It's called the Pinwheel Galaxy, or M101. And we're looking, this is what we call a grand design galaxy. We're looking right straight down at it flat. And the other one was at a 45-degree angle. So you can see the spiral arms coming out here, all out of the center. And we find galaxies, for the most part, all seem to have a very bright center, and there's pretty good evidence that they almost all have giant galactic black holes equal to 1 billion suns combined. So if you ever go to visit a galaxy, don't go there. Bad place to go. These arms are made of stars. Go visit one of those. They're much, much, much friendlier. The other thing you'll notice, this is a very beautiful galaxy, but you see all those little pink patches. Those aren't stars. Those are nebulas like the Orion Nebula or the Rosette Nebula. So we see lots of nebulosity. And remember, those are the places where stars are forming. So this is a very active galaxy with lots of star formation going on. You can see some here. You can see some here, little spots here and there. And there are lots of stars here, too. Almost all the light you see that looks like fog is just millions and millions of stars. This galaxy is bigger than the Andromeda, and it's bigger than the Milky Way. This has about 1 trillion stars in it. Now, these numbers are pretty big. We've talked about something being millions of light years away, and then there are billions of stars, and this has 1 trillion stars. And I find when I teach kids all the time, and I find they don't understand the difference between 1 million and 1 billion and 1 trillion. Let me give you a way to think about it. 1 million seconds is 11.5 days. A fourth grader understands 11 days. So 11 and a half days, that's a million seconds. A billion seconds is 31 and a half years. So it's a huge difference from a million to a billion, 31 and a half years. And a trillion seconds is 31,500 years. Another really big jump. So when we say this has a trillion stars, that's way more than a million stars. It's a really, really big deal and a really big object. And this Pinwheel Galaxy is 170,000 light years across, whereas our Milky Way is about 100,000 light years across. It's almost twice as wide, and it's about 250 million light years distance. So it's 100 times further away than Andromeda, but it's pretty spectacular if you've got a telescope good enough to see it. So we've seen the spiral galaxy straight on. We've seen it at 45-degree angle. Let me show you one more that I really, really like. Come over to the Big Dipper. I'm just backing off here a little bit. And if you look under the Big Dipper, you're going to find a springtime constellation. Now, you might say it's February. It's not spring yet. Well, when this constellation comes up, it means spring is on the way. You know, it was Groundhog Day a few days ago, right? February 2nd. Groundhog Day is a cross-quarter day. And what that means is cross-quarter days are the midday of a season. We're halfway through winter. Well, actually, right now, we are more than halfway through winter because halfway point was Groundhog Day, that cross-quarter day. So we're moving towards spring. And if you're into the stars, as soon as you see Leo the lion up here in the sky, you know that spring is on its way, because this is one you see all through the spring. You'll stay up to about the 4th of July, then it disappears in the glare of the sun. So it's on its way. To see Leo, you look, first of all, for an asterism that looks like a backwards question mark. This bright star Regulus is the dot. You come up, then it curves around, and it makes a nice question mark shape when it's facing the wrong way. It's backwards. So that's the question mark, also sometimes called the sickle, with the sickle blade here and a handle down here. To turn it into a lion, we imagine this is the lion's mane. And I usually just connect that circle, even though there are no stars over here, and let that be his whole head. His face is here where there aren't any stars. This big rectangle shape, it's actually a polygon, but it's close to a rectangle. That's his body. I give him a couple front legs, one front leg here and one down here. Come back his belly, there's a hind leg down to this star and another one up to this star. And then we come all the way up to Denobla, which is Arabic for tail. So that's the lion's tail right there. Makes a pretty good lion. We put some pictures on there so you can visualize it a little bit better. Well, right behind the lion, you can see another open cluster of stars. See how there's a group of stars right in here, right above the northeastern horizon. This is called the Coma cluster. Now remember, open clusters are young stars. And this is the second closest open cluster to us. The closest one is the face of the bowl. That's a cluster called the Hyades. And that's the closest open cluster. And it's a little more dispersed because we're so close to it. It doesn't look so tight together. This is the second closest one. It's about 280 light years away. And these stars are all a little bit older than like the Pleiades, which I said were 70 or 80 million years old. These are about 450 million years old. So it's a nice cluster. It's one really pretty to kind of explore with binoculars. But another reason to explore the Coma cluster is that this is a cluster on top of a cluster. The Coma cluster is an open cluster of young stars. But behind it, back in the distance, with your binoculars, and even better with a telescope, you're going to start noticing some other interesting little things. See this thing right here? That's a galaxy. This one's a galaxy. And there's the Coma cluster of galaxies. Now, we've just talked about a million, billion, trillion, right? There are a trillion galaxies that we know of. That's a lot of galaxies, maybe 2 trillion. But they aren't just evenly spread through the heavens. They clump together, and there are clusters. There's the Virgo supercluster. Well, this is the Coma cluster. And it's behind the Coma cluster of stars is the Coma cluster of galaxies, and there are about 1,000 galaxies here. And I want to show you just one of them. This is one right here. It's called the Silver Needle Galaxy. And it's another spiral galaxy. You can see a distant one in the background there. But this one we're looking at exactly edge on. So look at that. So if you could fly off to the side and look down at it from either side, perpendicular to the way we're looking now, it would look like perhaps like the Pinwheel Galaxy we just saw up by the Big Dipper. If you looked at it at a 45-degree angle, it would look like the Andromeda Galaxy. Well, this is what those would look like if you could fly to the edges and look edge on. So you can see these spiral galaxies are round, but they're kind of flat like a plate or a frisbee with that bulge in the middle where the super massive galactic black hole might be. So think about our Milky Way that we saw, that band going above Orion and across the sky. That goes all the way around us because we're inside the Milky Way. If this were the Milky Way, the sun would be about out here. We're not in the center because that's a giant black hole in there. We're out about a little more than halfway and about halfway through the thickness. So when you look towards in the summertime and you see the Milky Way, it's like looking in towards the center. In the winter, when we look above Orion, we're looking out towards this direction. And when you look towards the dippers, it's like looking one direction this way. When you look over towards Jupiter, it's like looking this way. There's stars above us and below us. They're all around us because we're inside a galaxy. So we'd be like in here if this were the Milky Way. And I hope that makes sense to how we're oriented when we look at the sky at night, because we can kind of vision that by looking at other galaxies. We've never gone outside the Milky Way, but by studying its structure, then studying all these other galaxies we see, we can really make some pretty profound assumptions about where we are and how it all works. And we can do that by studying each other, the other galaxies. So that's this is called the Silver Needle Galaxy, or NGC 4244. And you might notice there's a little more distant galaxy here and a much more distant galaxy there. Sometimes, especially when you take photographs of things like this, I always like to look at the object I photograph, but then look in the background stars. You'll see a bunch of stars there, but you'll often see other distant galaxies because there are hundreds of them out there. And if we back off here, you can see one up here. You can see one down here. If we started scanning around, you'd find them scattered all over the place here. So it's just a rich, rich area to look. There's one right there, and there's two right there. Oh, they're just all over the place. And while we're on the galaxy thing, I'm going to show you my favorite. It's called the Leo triplet. So go back to Leo. You see Leo the lion here. Go to his hind legs. I know they don't draw him in, but remember I have one here and one here. Go right behind his back leg, right about there. And you're going to find what's known as the Leo triplet, three galaxies, all in one field of view with your telescope. You won't see it with binoculars, but you can see all three of them in a wide field of view with a telescope. So this is M65, M66, and the Hamburger Galaxy. That one's not an M number. Now you may wonder, I've been using all these M numbers. The M numbers stand for Messier. And in the 18th century, there was a French astronomer named Charles Messier, and he wasn't interested in these things. He was interested in comets. He was trying to discover new comets. And in telescopes back then, these don't look nearly as crisp and clear as they do in this program. They look like fuzzy objects, kind of like I showed you Andromeda would look in your binoculars. Well, he could see faint things, but they kind of look fuzzy like that binocular view we saw of the Andromeda Galaxy. And they were easily confused with comets. Now, over time, you could tell they weren't comets because comets move, and these things don't move against the stars. They stay put. And he just didn't want to waste time looking at something, hoping it was a comet, and find it's just one of these objects. So he started cataloging them. He cataloged 110 of them, and it's called the Messier catalog. And it's some of the most outstanding objects in the night sky. Not every object, but some of the best ones. And so when people first get interested in looking at the sky with their telescope, they often concentrate on a lot of the Messier objects because they're some of the brighter ones and some of the more famous ones. And there are some challenging ones, but some of them are easier to find. These three are pretty easy to find because of their location right behind the back leg of Leo the lion. Now, I want you to notice a couple things. Look at M 65 and 66. This is 66 and this is 65. If you look at 65 first, you notice that there aren't many pink patches like we saw in the pinwheel. That means there's not an awful lot of star formation going on in this galaxy. And what we've learned is that galaxies sometimes collide with each other. When they collide, there aren't many collisions because the spaces between stars are too great, but their gravitational interacts and it kind of stirs up the loose hydrogen that's just floating willy-nilly and gets these star formation regions going. This one doesn't have any. But look at its neighbor, M66 over here. Let's back off. It's easier to scan over. And you might see lots of pink patches here. Well, this one's obviously got lots of star formations going on. And what they think is if we look up at the Hamburger galaxy, the one that Messier didn't pay any attention to for some reason, um, it has some star formations going on too. We're looking edge on to this one, kind of like we did the Silver Needle galaxy. And because of we can detect that they are moving, and the way they're moving, we're pretty sure the Hamburger galaxy and M66, the one with the star formations, collided millions of years ago. And when they collided, they created the star formation regions. And you can see some here. They're a little harder to see here because we got a lot of dust in the vein of the galaxy right through here, looking edge on again. So you can kind of see how we got the name Hamburger Galaxy. It kind of looks like a bun with a dark burger in the middle. It has another name though, and it's a name I like. It's called Sarah's Galaxy. And you might say, well, what's that all about? Well, there was a poet. Her name was Sarah Williams. She was born in 1837 and died in 1868. And she wrote a poem that's beloved by many astronomy people like myself. It's called The Old Astronomer. And it's well known for the last couple lines, which I'd like to read to you. And she wrote, though my soul may set in darkness, it will rise in perfect light. I have loved the stars too truly to be fearful of the night. And I always like that because when you get to know the stars, you realize there's something very comforting in them. And, uh, and they're just words that speak to my heart. So I like that. And I like the fact that they've named this galaxy after her. To me, it's a more appropriate name than the Hamburger Galaxy, even though it does kind of look like it's back way off here. And let's go back to our Big Dipper, something we're all familiar with. Now, once you find the Big Dipper, the next thing most people want to find is the Little Dipper, right? To find the Little Dipper, go to the back two stars of the pot. They're called the pointer stars because if you draw a line up through them, their name's American Doobie. Draw a line from Eric to Doobie and keep on going. It's going to point you to this star. And that star right there, believe it or not, that's probably the most famous star in the entire night sky. That's Polaris, probably better known as the North Star. And if you look at it straight on, you find it's directly above the direction of north. That's because it's directly above the North Pole. If you were standing at the North Pole, it'd be straight above you, right at the zenith. Well, if you're in Rangeley, it's not going to be straight up. It's going to be 45 degrees up. As a matter of fact, if you can measure the angle from the north horizon, or the closest point to the ground, to the North Star, in degrees, it'll always equal your latitude. Now, I happen to know Rangeley's right on the 45th parallel. There's that little sign right there in town. You've probably all seen that. And if you're standing in Rangeley or anywhere around there and you had a sextant or even a protractor and measured the angle from here to here, you'd find it's exactly 45 degrees up in Rangeley. Where I'm in Waterville, we're at 44 degrees. So we're a little bit further south. So it's going to be 44 degrees up. If you're at the equator, your latitude is 0. The North Star at the equator is sitting on the horizon, 0 degrees up. Think about it. If you're at the North Pole, your latitude is 90. Straight up from the horizon is 90 degrees. It's always equal to your latitude. In the days of the great explorers coming across the Atlantic Ocean, that was the primary thing they used for celestial navigation. The modern celestial navigation wasn't quite as developed back then, but they knew that if you kept that star the same height above the horizon, that meant you weren't drifting north and you weren't drifting south. You were always going east or west. If it starts getting lower in the sky, that means you're drifting southward. And if it's getting higher in the sky, you're drifting northward. So the explorers used that star. It also marks the end of the handle of the much fainter Little Dipper. You can see the handle bends down like this, and this little square is the pot. Always kind of hangs down towards the handle of the Big Dipper. So find the pointer stars, they take you to Polaris, and then the Little Dipper hangs back down towards the handle of the Big Dipper. And if you come down the handle, the Big Dipper, go to that middle star right there. Look at it carefully. How many stars do you see there? Probably at a glance, you see one, right? Well, if you're at Rangeley and you have nice sharp eyes, you might get a sense that there's more than one there. Does it look a little more oval shaped now? Get out your binoculars and you'll quickly see it's two. And if you have decent binoculars with a good resolving power, you might notice there's a star in between the two. The brightest star's name is Mizar. The slightly fainter one is called Alcor. And the third one is called Ludwig star. And Alcor and Mizar are both about 83 light years away. We're not sure if they're an orbital binary, but they are related to each other. They're probably gravitationally bound together, whereas Ludwig star is over 150 light years away. It's just photobombing the scene. It's way off in the distance. From what I've read, it may actually be the faintest star that's actually been named. All the stars have the visible stars have catalog numbers or numbers associated with their coordinates. Only bright stars have names, but Ludwig star may be one of the faintest stars with a name. This named after a German prince of the 18th century. So what started out as one has quickly turned into three. Now we're looking at it with binoculars. Get a telescope and look at Mizar and watch what it does. Mizar is this bright one right here. Zoom in on it, and with your telescope, oh, did you see how it split into two? It's actually two stars orbiting each other. It's a binary star. So now Mizar is two stars. And interestingly, what scientists often do when they look at stars is they don't just look at them. They'll take the light of the star and put it through a prism to make a spectrum or like a rainbow, right? And that spectrum can tell us lots of information about a star. It can actually tell us what it's made of and how fast it's going, whether it's coming at us or going away from us. Is a big explanation how they do that, but it makes sense if you break it down. What they find with Mizar A and Mizar B, these two here, is Mizar A has two spectrums, and Mizar B has two spectrums. That means Mizar A is actually two stars, and so is Mizar B. So this is actually four stars. When they look at Alcor, we can't break it into two stars visually, but it has two spectrums, which means it's two stars as well. So this is two and this is four. And if you add in Ludwig star, that's seven stars. At a glance, they all look like one. So just kind of interesting thing to look at. Take a look at that star with just your eyes on a nice clear night, and you can, if you have really sharp eyesight, you can see Alcor and Mizar. With binoculars, you might pull in Ludwig star. With a telescope, you can split Mizar into A and B. And then if you know some of the astronomy, you can realize it's even more than that, which I think is really, really fascinating. All right. Well, I think I'm going to leave you with that this evening, but let's just take a quick review to finish up here. Come back to the south, look in the southwest, and you're going to find the brightest thing you'll see will be the planet Jupiter, remember. Off to the south of Jupiter, you'll find Orion the Hunter. Look for his three stars in a row. For his belt, the reddish star on his shoulder, Betelgeuse. Kids often ask me, where did they come up with a name like that? Kids love these names. It comes from ancient Arabic, and it describes the part of Orion's body it marks. Now you see this is his belt and his two legs, and these are his two shoulders, right? But when you think about it, he's got his arm up. And if you look at that spot on someone's body when they have their arm up, what are you looking at? Not their shoulder, you're looking at their armpit. The word Betelgeuse supposedly literally means the armpit of the great one. Well, so much for romantic star names, right? So there's Betelgeuse. And Betelgeuse, by the way, is a giant star. And when I say big, I mean really big. If the sun, which is 1,200,000 times bigger than the Earth, nothing to sneeze at, if the sun were the size of a beach ball and you put it on the shore of Rangeley Lake, you brought Betelgeuse over, Betelgeuse would be as big in diameter. Its diameter would be as tall as Saddleback Mountain. It'd be about a quarter mile in diameter. It's a huge, huge star. And that's with the sun being the size of a beach ball. So it is a giant, giant star. And it's one that may supernova at one point. It's near the end of its life. It's not an old star, it's a massive star. And massive stars burn their fuel hard and they die young. This one's no older than the Pleiades, only about 80 million years old. So it's like a teenage star, but it's been burning its fuel ferociously, whereas smaller stars burn their fuel slowly and last for a long time. So this one is about ready to blow. It could blow tomorrow. It could blow in a million years. Because remember, for a star, a million years is like not really that long because they can last for billions at times. Our sun will last for at least 10 billion years, probably. So this is one that could explode. That would be exciting if it did. It wouldn't hurt us. It's too far away, but it would make quite a sight to see. The Orion Nebula is down in his sword. which you can see with binoculars. The even though you can see that red spot there, you won't see that with your eyes. That's the Rosette Nebula we saw. Go up through Orion's belt, past the face, there's the Hyades, the closest open cluster to us. Go past them, you come to the Pleiades, one of the prettiest sights you'll see in your binoculars. Both the Pleiades and the Hyades are fun to look at with binoculars. They're large areas of dense stars and just a delight to explore. Aldebaran has an orangish color, so it really stands out against the other stars. And by the way, Aldebaran's not part of the Hyades cluster, just like we saw that planetary nebula is floating in front of the open cluster and M47. This is floating in front of the Hyades. The Hyades is about 160 light years away, whereas Aldebaran's only about 65. You have to keep reminding ourselves that space is three-dimensional. Not everything's the same distance from us. Go down through Orion's belt to Sirius, the brightest star in the sky, and you find Canis Major, the big dog. Go above it, we find Canis Minor, the little hot dog. And between the dogs and going above Orion, we see our own Milky Way. That's our galaxy, and we're inside of it. This is like looking towards that outer edge of the rim of the galaxy. That's what we see in the wintertime. In the summertime, we're looking at the other side. Now, we can't do this here because you see it's below the horizon for us. One thing we can do here, though, using a program like this, is we can just make the ground disappear. And then you can see, look all the way around, and you see how much brighter it is down in here, because that's like looking in towards the center of our galaxy, right down. Let's see if I can get it to come up here. There we go. And in the fall, this part is where we can see it. We can't see it right now, but we're cheating here a little bit by erasing the ground like we were floating in outer space. Let's bring the ground back up and keep us here safe and sound where we know where we are. Follow it over to the northwest, you find Cassiopeia the Queen and Andromeda Princess, and the most distant point of light you can see without a telescope, the Andromeda Galaxy. And then you swing around all the way to the north, and we find the two dippers, the Little Dipper and the Big Dipper, which is Ursa Major and Ursa Minor, the Big Bear and the Little Bear. Put up their pictures, and you can kind of see them there. And then if you want to find Leo the Lion, here's the secret. Go out and find the Big Dipper. Don't worry about the bear, just find the dipper. Once you find the dipper, just pretend to grab that dipper by the handle, take that pot and bang it down, and you'll hit Leo right smack in the back of the head. He doesn't mind at all. Just don't go doing that to real lions. I hear they don't like it so much. All right, well, that's the sky for tonight. I think we've pretty much used up our time here, and I hope that in March, the weather is a little clearer for our decision making about whether to hold an actual star party outdoors. The weather was just too iffy today. We couldn't decide. The forecast was for partial clouds, and you never know what you're going to get with that. And at the last minute, we decided it was the better to do this tonight. And whether that's true or not, it is what we did, and this is where we are tonight. I really would like to get up to Rangeley and look at the sky with some of you outdoors, and hopefully we'll get to do that next month. So if anyone has questions, I'll be glad to take any questions for you. And you can, I know I saw a couple things that someone wrote something in the chat, but
So I popped a couple of things in the chat, John. I found the Stellarium mobile app for both Android and Apple and was able to put those links in there for everybody. I also had one question come in. The question is really, I find it hard to see the constellation. How does one develop the skill and knowledge?
how does one, I'm sorry, you broke up on me a little bit there. How does
How
they find
does
a
one
huge
develop
constellation?
the skill and knowledge to find the constellations?
It just takes, it's like anything else, it takes time. I do this a lot. And I know that when you do it online, sometimes just like you did for me a minute ago, the voice breaks up or the image is a little soft or something. If you're outdoors with someone like myself, or there are a lot of us who love this and we're glad to teach it. And what I hear a lot is people say, when I'm standing next to you and you're pointing it out, I see it so well. And then you go away and I go out the next night and I can't find it at all. And I understand that. It's like anything you try to do that you don't do a lot. People say, how do you remember all this? Well, I teach it every single day in the planetarium. And so it's kind of ingrained into my brain at this point. It just takes time. And what I suggest is don't try to learn them all. if you think about what you already know, do you know the Big Dipper? Can you find Orion's belt? Can you find Orion? Remember, draw a line down through his belt and find Sirius. Go up through his belt and find the Pleiades and the Hyades. And once you get so you can just do that and you don't have to like think about it, then you might add, well, that bright star is part of the dog, maybe his collar or his nose or something. And these, like, I taught a class last spring for Maine guides, and we're going to do that again this spring if you're a Maine guide. And about 3 weeks into the class, one guy said, I'm never going to learn all this. I said, yeah, but have you learned anything? I said, what did you know before you started? He said, I knew the Dippers and Cassiopeia and Orion. And he says, but I do know the dogs now, and I know Leo. I said, well, you just doubled your knowledge. Be happy with that. So you know that. And then you can pick on another one and do it slowly. Don't feel you have to learn all at once. That's just overwhelming. I don't know. There are 88 constellations. I don't know all 88. There's some I just can't find. And I probably will never know them all. And you don't have to know them all. Just learn a few. And if that makes you happy, then that's fine. And if you like that and you want to learn some more, then pick a couple and work at it. And it just takes time, and enjoy the process of learning. We have the sense we want to just know it. It's like, I want to know how to play the piano. Like, well, it takes practice. It takes practice to do anything. I'm like that with signing. I work with kids, and about once every couple of weeks, I get a hearing impaired student. I always wish I knew how to sign and say, at least introduce myself. And I'm always afraid I'm going to swear at them or something because I just don't know what I'm doing. And I don't do it enough that it gets burned into my synapses. And so I understand where you're coming from with that. Any other questions? If someone has a question, they're welcome to speak up if they, unmute and speak up if that's a possibility, or you can write it in the chat.
We'll give it
No?
another moment for a few questions, but until then, I am going to just reiterate, Rangeley is in the path of totality on April 8th for our total solar eclipse, and it's going to be amazing here. So we highly recommend that you check out all the programs we have lined up from the 2nd to the 8th and join us. And with no more questions coming in, I'd just like to say thank you to everybody for joining us. And thank you again for John for being such an amazing presenter. We're very grateful for your knowledge.
Well, thank you for having me back again. I enjoy all my virtual trips and real trips with the Rangeley Lakes Heritage Trust. It's a wonderful organization. You should definitely support it and take part and get somewhere where you can see that eclipse, because it's going to be an amazing, amazing event. If you've never seen a total eclipse, you should see one. The next one in Maine won't be till 2079. And that's a couple of years down the pike. So you want to get a chance to see this one. It's one of the most amazing things you'll ever witness.